Hello students, welcome back to maths class. So we are dealing with the maxima and minima problems, right? So in this maxima and minima, what I said, how we have to find any functions, maxima or minima. Function means any equation, right? So volume can be maximum, area can be maximum, right? So how we will find the maxima and the minima means first we have to take that function, differentiate it with the, suppose the function is in terms of r, in terms of r, suppose function is in terms of x, in terms of x we have to differentiate. Equate to 0, you will get some value. At that point your function attains either maximum or minimum. Next, whether it attains maximum or minimum, you find out its second derivative, right? So then you will know if your second derivative is less than 0, negative, function attains maximum. I said reversely, if your second derivative is positive, function attains minimum. Okay, so now come to the problem. So from a rectangular sheet of dimensions 30 centimeters into 80 centimeters, 4 equal squares of side x centimeters are removed at the corners and the sides are then turned up so as to form an open rectangular box. Right, find the value of x so that the volume of the box is greatest. So volume of the box is greatest. Greatest means maximum, least means minimum, right? Instead of maximum we can say greatest, instead of minimum we can say least also. Okay, so now if you observe, this is the sheet, right? Okay, so with the dimensions, right, 80 centimeters and 30 centimeters, length is 80 and breadth is 30 centimeters. From that sheet, in corners, right, squares of x side, so this is one square of side x, this is one square of side x, this is one square of side x, they are removed. Right, after removing, just turn the sides, you will get one rectangular box. That box volume you have to find. So suppose you are having the sheet, rectangular sheet like this, right? So here are the 4 squares, right, with the equal sides, right? All 4 will have equal sides. Just you remove the 4 sides of the, right, rectangular sheet and just you turn up, right? You turn these 4 sides into, right, corners. We have to take squares and remove and you take like this. You will form one rectangular box of height x. Here we have taken x, so your height of the rectangular box is, this height is x, here also x, y. We have taken here x and here also x. So we are folding like this. So what is the height of your rectangular box? That is x. Okay. So now we have to find when, at what point this rectangular box volume is greatest. Okay. So come on, now you take the question, right? Let L, B and H are length, right? Length, breadth, okay, breadth and height of the sheet, or we can take a rectangular box, right? So of the rectangular box, okay. So since the square of side x is removed from the sheet, right, since the square, okay, square of side x is removed, right, removed, all 4 sides of square of x removed, okay, from the sheet, right, Now your length will be totally it is 80. So this is x, deleted. So your length of your box is now 80 minus 2x, right? And breadth, right? Your breadth is 30, right? So in this 30, okay, so this corner, we have to delete the squares. So here x distance, here x distance. So this is your breadth of the rectangular box. So 30 minus 2x, right? And height is equal to x. Okay, just if we after removing, if turn the sides upwards, that is height, that is nothing but x. Now you take volume of the box. Volume of the box is equal to, what is the formula? Length into breadth into height. Okay, so is equal to, here length, what is your length? From here we can write it is 80 minus 2x, 30 minus 2x into x. So is equal to 80 minus 2x into 30x minus 2x square. So is equal to 8 3s are, right? 24 0 0 x minus with 80 multiplying these two, right? 8 2s are, right? 16 x square. Now with minus 2x, right? 2 3s are 60 x square, minus into minus plus, it is 4 x cube. Okay, so your volume V is equal to, writing in the order, what is that? 4 x cube. Next x square terms, minus 160, 60 minus 220 x square, right? Next plus 2400 x. Okay, so this is your volume function. So here it is given that at what value of x this volume, right? At what value of x volume of the box is greatest. Okay, so we have to find at what value of x this volume. Now you got your function in terms of x. So when we will get the function as maximum or minimum, at which point? First derivative, right? So volume attains maximum or minimum at dv by dx is equal to 0, first derivative. So come on, dv by dx. So d by dx of v is 4x cube minus 220 x square plus 2400 x. Okay, so whenever plus minus we have to take separate derivatives. So d by dx of 4x cube minus d by dx of 220 x square plus d by dx of 2400 x. So come on, you know how to differentiate. 4 into d by dx of x cube is 3x square minus 220 is a constant, d by dx of x square is 2x plus 2400. So is equal to 12x square minus 440x plus 2400. Equate dv by dx to 0. right? So is equal to 12x square minus 440x plus 2400 is equal to 0. So which number can be taken common? We can take 4 as common, right? We can take 4, then 3x square minus 110x plus 600 is equal to 0. Sending 4, that side 0 by anything is 0. So 3x square minus 110x plus 600 is equal to 0. Now we have to get the factors for this so that we can get x value. At that x value, function attains either maximum or minimum. How we will get factors? First we have to multiply 600 with x square coefficient 3. So it is 1800, right? So find out with 90, right? So 90 into 20. If you add 90 into 20, you will get your minus 90 minus 20, right? You will get your minus 110. So it is 3x square minus 90x minus 20x plus 600 is equal to 0. So next, come on, 3x taken outside, then x minus 30. Sorry, so next minus 20 can be taken outside. So it is x minus 30 is equal to 0. So which is common? X minus 30 is common. So we can take 3x minus 20 is equal to 0. So come on, x minus 30 is equal to 0 and 3x minus 20 is equal to 0. So x is equal to 30 and 3x is equal to 20, x is equal to 20 by 3. Okay, so come on, observe carefully, x is equal to 30. If we take x is equal to 30, what happens to your value? 30 minus 2 into 30, right? So 2 into 30 means 30 minus 60 minus 30, your breadth will be minus. We don't take length, breadth, height, positive values only, right? We don't say any time, so minus kilometers, minus 5 kilometers, minus 7 kilometers, we don't say. Just we will say, I crossed the distance 5 kilometers, right? It must be positive, right? Length, breadth, height, all must be positive. So if we take x is equal to 30, your breadth will be negative. So we can't take x is equal to 30. So we can take x is equal to 20 by 3 only. Okay. Now we have to check whether the volume actually at this point the function attains either maximum or minimum. But a question, the function must attain maximum at that point we have to find. So to know, right, to check, right, to check the function attains maxima or minimum, we have to find which value? D square v by dx square. So come on, d square v by dx square is equal to d by dx of dv by dx. So d by dx of dv by dx. What is our dv by dx? This is our dv by dx. So it is 12x square minus 440x plus 2400. So take separate derivatives. D by dx of 12x square minus d by dx of 440x plus d by dx of 2400. Okay, so is equal to, it is 12 d by dx of x square is 2x minus 440 d by dx of x is 1 plus d by dx of number is 0. So is equal to 12 2s are 24x minus 440. So now you find out d square v by dx square at x is equal to 20 by 3. Right. Suppose if we get that value as a negative, volume attains maximum. Okay. So is equal to, it is 2420 by 3 minus 440. Okay. So 3 8s. So it is 160 minus 440. Okay. So is equal to, minus of higher value is minus, it is 280 which is less than 0. Therefore, volume of box is greatest, right? So greatest at x is equal to 20 by 3. That is the answer. Okay, so greatest means maximum, right? Sometimes they can say greatest, sometimes they can say maximum. Okay, so this is 7 marks question. Okay, so what is this? One sheet is given to you with a dimension of, that means length of 80 centimeters and breadth of 30 centimeters. In the four corners, a square of x side, right? A square of side x, right? All four sides will be x only, right? Such squares are turned out, right? Removed, and then it is folded upside, right? This part is folded upwards. Then you can form one rectangular box. Then height will be x and your length will be this side x removed, this side x removed. So your length will be 80 minus 2x. Same thing with breadth also, that side this side x removed. So 30 minus 2x. And height is that height we just lifted the part, right? Square part upwards. So height is x, right? Then you take a volume of the box, formula length, breadth, height. Okay, so you take this one and simplify, you will get one equation in terms of x, right? So your volume is in terms of x. This is our function, right? So we have to find out at which value of x this volume is greatest. Greatest means maximum. Okay, so how we will find this one? What is the procedure? I said same format. What is that? First time derivative, right? dv by dx. So equate that dv by dx to 0. At that point, the function attains either maximum or minimum. So that's why dv by dx we have taken. We got the differential equation. Then equate dv by dx to 0, right? That equation to 0 and try to get your x value. We got 2x values here, right? But if we take x is equal to 30, we are getting negative breadth, isn't it? What is our breadth of the box? 30 minus 2x. So 30 minus 60 means minus 30, which is meaningless. So we cannot take this one and we will go for this one. So x is equal to 20 by 3. The function attains either maximum or minimum. So if we want to know exactly whether it attains maximum or minimum, we have to find d square v by dx square, second time derivative. Okay, so in that you substitute your x value. If your d square v by dx square is negative, volume is greatest. We got negative only, so your volume is greatest at x is equal to 20 by 3. Okay, so same concept, only thing is here you have to remember this formula. Volume of rectangular box, right? Volume of rectangular box is length into breadth into height. Okay, and how we have taken after removing the squares, right? So what will be the length of that box, what will be the breadth of that box, and what will be the height of the box? You should be careful with those values, right? Take the values correctly, then you take volume. Actually here it is given that volume of the box is greatest. Okay, so we have to find that x value where the volume of the box is maximum or greatest. Okay, so try to write volume in terms of x equation and differentiate one time, equate to 0, you will get x. At that, volume attains either maximum or minimum. Again differentiate it and substitute this x value in it. If you get negative value, the volume attains greatest value at that x. Okay, so therefore what is our x here? X is equal to 20 by 3. Okay, so practice this problem perfectly. This is a little bit different, no? Enjoy such problems, right? So that's all for today. Have a nice day.